In the vast darkness of space, sci-fi gives us two iconic images: a hidden fleet shrouded in a cosmic cloud and a lonely ship orbiting under a dim red sun. But these aren't just cool visuals. They're based on two real and wildly different cosmic phenomena: the brown dwarf and the red dwarf. One is a failed star, the other an eternal ember. Today, we're using real NASA science to explore the difference and find out which one sci-fi gets right. Let's start with the universe's ultimate underachiever, the brown dwarf. To understand it, we need to know how stars are born. They form from colossal clouds of gas and dust, collapsing under their own gravity. But here's the catch. You need enough mass to become a star. If an object has less than about 75 times the mass of Jupiter, it never gets hot enough to fuse regular hydrogen. This is the brown dwarf's dilemma. It's stuck in cosmic puberty. Too big to be a planet, too small to be a true star. So, what does it burn? For a short stellar adolescence, it fuses deuterium, or heavy hydrogen. It's a weaker, inefficient fuel. Imagine trying to power a sports car with firewood. It'll glow for a bit, but it can't sustain itself. After a few million years, the deuterium is gone, and the brown dwarf's fate is sealed. It slowly cools and fades into darkness. And this is why Star Wars is scientifically brilliant for using them as hidden bases. A brown dwarf emits very little visible light. It's a dark, cold, and lonely place. Hiding a fleet here isn't just a cool idea, it's strategically sound. It's the ultimate cosmic stealth technology. Now, let's meet its cousin, the red dwarf. If brown dwarfs are the failed teenagers, red dwarfs are the quiet, efficient, and incredibly patient elders of the galaxy. They are true stars, successfully fusing hydrogen into helium in their cores. But they do it slowly and efficiently, like a hybrid car compared to a gas-guzzling muscle car. This efficiency gives them an astonishing superpower: longevity. Our sun will live for about 10 billion years. A typical red dwarf? They can theoretically shine for up to 10 trillion years. They will be the last stars burning in the universe, long after stars like our sun have died out. This brings us back to Interstellar. The dim crimson light bathing the Endurance is exactly what you'd experience. Planets need to orbit hugging a red dwarf to be warm enough for life. But this comes with a catch. These close orbits cause tidal locking, meaning one side of the planet has eternal daylight, and the other, eternal night. Imagine a world with a blazing hot desert on one side, a frozen wasteland on the other, and a narrow, potentially habitable ribbon of twilight in between. This is the reality of life in a red dwarf system. So, let's get to the main event, the ultimate cosmic showdown. How do these two stellar underdogs, the brown dwarf and the red dwarf, truly stack up against each other? First, the fusion engine. In this corner, the brown dwarf, relying on a short-lived, sputtering deuterium engine. It's a flash in the pan. And in the other corner, the red dwarf, powered by the full, relentless, trillion-year fire of hydrogen fusion. It is the ultimate endurance runner. Next, temperature. The brown dwarf is cosmic lukewarm, with some so cool you could theoretically touch them. They're barely hotter than a campfire. But the red dwarf, it's a roaring furnace, still blazing at a toasty 3,500 degrees Celsius. It's the difference between a fading ember and a persistent, glowing coal. Now, for lifespan. This is where the contrast becomes almost unimaginable. The brown dwarf puts on a faint light show for a mere millions of years. But the red dwarf. The red dwarf will still be shining for trillions of years. It will outlive galaxies as we know them. And finally, the sci-fi trope. What are they known for in our stories? The brown dwarf is the ultimate stealth operator, the perfect shadow for a hidden base, a smuggler's outpost, a secret fleet. But the red dwarf, it's the ancient patient sun, casting its dim crimson light on strange tide-locked worlds, where life might cling to existence in a perpetual twilight. So, who wins this cosmic battle? The answer is, it depends entirely on what you're looking for. If you need the perfect cosmic cloak, a place of shadows and secrets, the brown dwarf is your undisputed champion. But if you seek a star that can nurture worlds and outlast time itself, then the red dwarf, the eternal ember, claims the crown. One is a fleeting ghost in the darkness. The other is a timeless monument to persistence. And this isn't just academic wonder. This is the reality of our galaxy's composition. Red dwarfs. They aren't rare curiosities. They make up about 75% of all stars in the Milky Way. They are the silent, burning majority. In fact, our very nearest stellar neighbor, the star closest to our sun, is a perfect example. Proxima Centauri, a classic red dwarf, just over 4 light-years away. It's a faint, flickering ember, utterly invisible to the naked eye from Earth. Yet it is the most common type of star in our cosmic backyard. But what about their cousins, the brown dwarfs? While they are much harder to spot, hiding in plain sight with their incredible dimness, astronomers now believe they are also incredibly common, lurking in the dark spaces between the bright stars. And their nature is truly bizarre. Their temperatures can range from a scorching 2,000 degrees Celsius when they're young, all the way down to below freezing, colder than a human body. They are cosmic chameleons of heat, fading from a faint glow to utter invisibility. So let's put this in perspective. The most typical star in our universe is not a brilliant yellow sun like our own. It is a dim, red, and incredibly long-lived dwarf, just like Proxima Centauri. And dancing in the shadows between them are countless failed stars, the brown dwarfs, neither truly star nor planet. Our own bright sun, the anchor of our solar system, is actually the exception, a less common class of star in a cosmos dominated by faint, enduring embers and dark, fading ghosts. This is the true big picture of our stellar neighborhood. So the next time you see these sci-fi landscapes, you'll know the real science. The brown dwarf is the universe's stealth cloak, but the red dwarf, it's the cosmic diesel engine. Not flashy, but built to run for trillions of years. So tell me, the shadowy hideout or the eternal ember? Which would you explore? Let me know in the comments, and subscribe for more journeys into the science behind the fiction. Thanks for watching.